What I would like to present today is yet another tool that we do use for providing better support to the research groups within the university. So again, let me just very quick recap. We don't claim these tools are the best you can find in the market. We don't claim they solve all the problems that you might have. I'm not here to sell anything, just to report our own experience, and we use this type of tool for fast response time to the research groups. Let's start with a very concrete example, and this tool, GC3Pie tool, goes in line with a statement that I made this morning when I said that we are now progressively going away from a batch cluster to direct control of the cloud infrastructure for the data processing part of what most of the use cases we do serve. So let's take a starting example, cloud-based social network analysis. This is a group from the business and finance department at the university. They do quantitative empirical research and network analysis. The main challenge they do have, this is a typical example of a researcher that have been developing some tool on his own workstation, and now he realized that that doesn't fit any longer. He doesn't know how to move away from this. But the user, when we approached the user to discuss with him the use case, he had a relatively simple R function that wanted to apply to every element of these gigantic tables. One typical example of a gigantic table is this 3.5 million entries, and for compute every entry within this table, it takes 1 to 2 minutes approximately. They have quite a few of them. So how did we help? First of all, we had the chance to look at the code finally, and not just to get a feedback from a user saying, I have something to run, please let me run on your infrastructure. So we explained him what the apply is, the apply function in R. I assume you're all familiar with R, and the difference between the apply and the MC apply was most importantly to make use of the available core on the nodes. That was already quite successful to a certain extent, but was already useful for us, because in this way we can apply the function that they have defined to either the whole or a segment of the input data. That was quite convenient, so I'll get to the point there. And then we use this tool, which is called GC3Pie. I will enter into detail of what it does. This is pretty much, I hope you can read it, the resolution is a little bit crap, but this is pretty much all we had to write, or they'll say 90% of what we had to write. This is an application class. We specialized a basic application class and create our own. Do I have the schema here? And then we created a customized Python script based on this type of library and how we customized the library that we negotiated with the user, with the group, the way they wanted to run the whole thing. So let's see how it works. Again, I should have the, yeah. This one is not yet on YouTube because it's very recently produced, like yesterday evening at 2 a.m. in the morning. So, okay. Anyhow, this is the perception of the cloud infrastructure from the user, and I hope I will be able to give you the impression why we believe that this tool like GC3Pie helps us a lot in this sense. So the user has this command line interface that can use to run its own analysis. This is a typical input file that he has to deal with, 100,000 entries. And the format is, here. And the format is relatively simple, so a very simple table. But he has to apply this specific R function for each of them. So what we do, what he does, he runs the script with one of the input file he has to run, some of the parameters that are relevant for him, like how much do we chunk the whole input file, or what is the size of the individual chunk that we will produce. How many simultaneous execution, this is just for the demo part. and what type of resource we will be running it. This is the, let's say, their view of our own cloud infrastructure. And the way it goes, and I'm pretty sure you will be very easily read all the debug information that will be published now, so it's easy to understand, right? Okay, let's skip the, sorry, maybe I can move this somehow. Yeah, let's skip the critical part, but I just wanted to point out is that this type of library can, can create application objects, can create application instances, this one, can identify resources where the application could run, and then it can try to connect to these resources and have the application to run. And as you should be able to see, as soon as you can connect to any of these resources, then you can move the data, prepare the whole environment, and trigger the simulation. And then at the same time, do you really see this? It's terrible. Sorry. Okay. What did you do with my screen resolution, Christian? Let me just very quickly see if I can readjust. It's too much time anyhow. What you should retain from here is that the library also controls the activation of the VMs and keep track of which are running, what is running where, and so on and so forth. So you will see that progressively it creates more and more instances depending on the size of the workload that has to be generated. And here, for example, I can show that. Sorry, I was missing one part. I can show that then I can log into the VMs directly and see that the whole system has been preparing, the whole library has been preparing the execution is going on. It creates some, it compartmentalizes the execution of the specific application, nothing more than that. But again, from the user perspective, what he retains, and here you see that progressively it increases the VMs because the workload is increasing. From the user perspective, it simply has a report of what's going on, how far did it go with its own execution. It sees some of the applications that are running, some that have been terminating, some that are terminating, some that are still new, that has to be assigned. So when everything is finished, he gets information that everything has been completed. In this particular case, all the results are assembled back into the original larger table that is enriched with an additional column, which is the value that has been processed for every element of the list. Nothing fancy in this respect, but from the user, everything is automated. And for us, we were able to write something like this that is very customized. Oh yes, by the way, at the end, everything is turned off. Okay, it doesn't really work this way. It terminates the VM the moment they are no longer necessary, not terminating them simultaneously just at the end. But again, we were able to come with this type of solution in pretty much three working days. 3 working days, including the whole learning part of trying to understand what it's trying to do with the application and the testing and everything. So what is GC3Pie? So GC3Pie is a Python library that we wrote explicitly to target the scenario where one needs to automate the execution of a large collection of our application, being them all the same or being them different type of application. But when I want to automate the execution, so the access to the resources, the supervision of the execution, the handling of the error, the post-processing eventually of the results, this is what this library is all for. The issue that we want to solve, the portability. Many of these use cases are handled by writing ad hoc Perl or Python, or Wish Python shell script that does some of the control logic, The portability is a huge issue. If I want to run the pipeline to another cluster, I know I mentioned this morning that through a cloud infrastructure probably we can replicate the environment, but this originates from also from other effort. It makes the portability of those type of solutions much more easier. The code we use, so scripts are very often written for making assumption on the infrastructure. With this library, we easily decouple the infrastructure detail from the application execution control logic. And the maintenance, indeed, most of the time you once start to write very simple scripts that does certain functionality and then start to realize that it would be better to have another functionality and yet another more and yet another more, and then you end up with a very complicated system that you don't recall what it does in the first place. So GC3Pie is a Python toolkit. It provides building block to write Python scripts. The focus is large computational campaigns, so a lot of applications that needs to be somehow scheduled and organized in what we call pipelines. It's very similar to workflows. It consists of 3 main libraries, so main components, a core library that is the programming framework, apps, which are the end-to-end solutions that we write depending on the use cases, and some utility that comes with. The programming model is based on the customization of base images. So you specialize existing classes, and through inheritance you create your own specialized class. It allows different level of control, so it does not provide a single type of, let's say, access model. Depending on the level of control you want to have, it can provide very generic high-level APIs like do everything, or it can expose also very fine-grained APIs for controlling the access to an individual resource, to instrument the scheduling of certain type of resources like the priority and the data movement part. For example, the session-based script is the highest level of abstraction that we normally use to encapsulate the apps that we write. GC3Pie runs specific application that it does not run jobs. An application is not a batch job in the way that we normally describe it with some very specific batch system directives. It runs an application. So typically an application maps what you would run on a command line if you would have access to an interactive session, pretty much. And again, one can write specialized application by customizing the basic application class. GC3Pie can run application in parallel, it can run them in sequence, or it can run any combination of them. So it is a workflow manager, but you don't describe the workflow, you program the workflow. So basically you write a Python script that is your workflow. It also has the advantage that you can adapt your workflow during the execution, because you can take programmatically some intervention to the way the workflow is organized. So this is basically the generic schema. The blue part is the library itself. The orange part is what we normally, or a developer needs to customize. Customize your own application because this is, let's say, the specific aspect of what you want to run is framed within an application. So what would you run and how would you run it? And the session-based script is simply the decorator part, like the main method in any program. So you write the main and you write the specialized application. And then you can group those applications in collection. Yeah. The execution of these collections is delegated to an engine. Still, this is all something that runs on the client side, so you don't have to instrument any complex deployment of this. An engine takes care of the scheduling of the application. It's like a batch system in that sense, but much more lightweight. And the access to the resources. The resource is a computational endpoint, and it can be any type of endpoint. It can be a cloud, it can be a batch queuing system, because we started with batch queuing system, then we evolved to computational grids, then we introduced the SSH connectivity to any remote resource, and then the local host, so you can run the very same things on your local host, and then finally we also have the cloud backend. And by cloud, we use the Boto library, so we use, for the moment, no, we have both the Boto libraries and the OpenStack API support. Of course, each resource has its own access method and its own authentication method, and this is all taken care within the library. One specializes on providing the access information through a configuration file, but then the engine takes care of the orchestration of and the access to the various type of resources. Then the session-based script already provide very easy mechanism to instrument this, plus a persistency, which is the relevant part in the sense that for long-running executions, you need to periodically persist stateful information in a way that you can restart all the time. So again, the engine manages all the jobs concurrently, so he has a global view of what he has to run. In this case, it's not job, it's application. And the task composition define the dependencies between an application, between the applications. So this is how you define your pretty much your workflow if you have to. And again, because this is a programming library, you can reorganize your workflow on the fly. That's pretty much everything. Oh, I was slower than I thought. I thought it would have used 5 minutes. Again, this is not really a product that we want to sell. It's just to give you an overview of yet another tool that we use to instrument, to provide support for porting those type of use cases that we have to deal on a regular basis on various type of infrastructure, because we started using GC3Pie again when we were using we were providing access to a local cluster, then a grid infrastructure, then a cloud infrastructure. Through this library, we can somehow detach from the underlying technology, and then we create a minimal disruption for the researchers, especially when they don't want to go through the learning curve or learning what type of infrastructure do they need to access. So we migrated a computational cluster for SunGrid Engine to Slurm, and that was completely transparent for them. We moved their own workload from a local cluster to a grid or a cloud infrastructure, and that was completely transparent for them. So here you find some information on the website and on the documentation. It has been a very, very long day, and I gave 3 talks, so thank you very much for your patience then.